Hello everybody, welcome to the channel. In this video, we will explore various techniques used for animation in video games. Now, performance constraints are crucial in video games compared to animating for films, as maintaining 60 FPS is essential. Therefore, the options available for animation are more limited than in offline media. Frame-based animation. This technique is usually used in 2D games where each frame of animation is hand-drawn. It requires high artistic skill, as each frame must be precise. However, the results can be awesome. There are some flaws in this technique, though. For instance, you cannot dynamically control the animation. For example, if the player is aiming at a target, the animation cannot dynamically adjust to point in that direction. Additionally, frame-based animation requires more storage space because you have to store image files for each action. Therefore, most games that use frame-based techniques are pixel games. For example, Dead Cells uses a frame-based approach, resulting in large file sizes, unlike Rayman Adventures, which uses bone-based animation. Bone-based animation is utilized in both 3D and 2D games. In this technique, specific bones are assigned to the body part, and when the bone moves, the corresponding part of the body moves as well. This approach is more beginner-friendly and easier to use compared to frame-based animation. However, understanding animation techniques is still crucial to ensure your animations look good and are effective. In this technique, we describe where the bones should be in each frame, and it will move to that point accordingly. Combining animations is a technique widely used in various AAA games like GTA, Red Dead Redemption, and CSGO. In these large-scale games, there are numerous animations required, and creating each one individually is not always the most efficient solution. For instance, consider having separate run-and-shoot animations. Instead of creating a brand new animation for running and shooting simultaneously, we can combine existing animations. Here's how it works. We take the upper part of the shoot animation and constrain the lower parts. Then we take the lower part of the run animation and constrain the upper part. By doing so, we create a new animation that blends the two actions seamlessly. Game engines provide functionality to achieve this, such as Unity's humanoid rig, which facilitates the blending of animations to create complex movements and interactions within the game world. Another technique used to enhance current animations is inverse kinematics, or IK. To understand IK, we first need to consider forward kinematics. In FK, we move each bone separately. For instance, to move the arm, we adjust the shoulder bone first, followed by the forearm, and so forth. On the other hand, in IK, we move the root bone, and the other bones adjust accordingly to the movement of the root bone. For instance, in a scenario where a player is picking up an item, IK can be employed. IK is utilized in various situations, such as accurate foot placement of characters, picking up items, and more. Lastly, there is the vertex-based animation technique. While skeletal animations are versatile and generally performance-friendly, they are best suited for characters, creatures, or anything with bones. They aren't ideal for soft, boneless objects, like beanbags, plaques, or paper. For these cases, we need a different approach, and vertex-based animation techniques come to the rescue. Imagine having a smooth page-turn animation created in Blender. Without a skeleton or keyframed animations to export, how can we incorporate this into a game engine? Animation textures contain vertex positions, normals, and tangents saved as textures. Each frame of animation occupies a single row of pixels, with each pixel corresponding to one vertex on the mesh. The red, green, and blue color channels read a row of pixels and apply the corresponding transformation to each vertex. By offsetting the UVs vertically, interpolation occurs from frame to frame, resulting in a hopefully smooth, bone-free animation in real time. I hope this video has been helpful for you, and see you in the next one. Bye.